Dear Professor, my name is Wei Xingyao. So next, let me introduce our group project. We choose the topic about the Kaitak Development Area Public Housing Construction Project. It's about construction schemes and the optimization analysis for the structure and foundation engineering. So we divide this project to 7 parts. This is our content. Let's start with the project background. So Hong Kong faced a service housing shortage. Kaita Development Area is a key land supply zone promoted by the government. And this project is construct Section A of the public housing works in Zone 4B of this area. So for the project positioning, medium-scale public engineering project belonging to the early structural works for new public housing. So planned by the Housing Bureau and coordinated by the Architectural Service Department. So for the project scope, it's about pre-drawing and plus the edge films foundations, 1 floor underground garage and core tubes, and the structure based for 1 to 6 ground floors. So supporting the service include continuous monitoring, the project control, cost estimation, and the optimization. And for our advantage, the medium-sized general contracting enterprise with the extensive experience in the relevant engineering constructing and the sufficient resource capabilities to undertake the project. And this is our methodology. It's about WBS and CPM, BOQ, and plus the unit price analysis, EVM, and the optimization model is about the linear program for the medium cost question.
Okay, in this session, I will introduce the project planning for everyone. And we usually use the work breakdown structure to break down the engineering projects. And only after the breakdown we can know what we need to do and how to make a work plan based on the test. And here is the project scope, and we roughly divide this program into 7 sections, and it is site preparation and foundation engineering and basement structure and above ground structure and concrete production and safety and environmental production, and finally have a inspection. And about this, we will about calculate this data. We get a project scope, we get a WBS chart above this, and we can clearly see the plan, the program's plan, and know what we should do. And after the optimize and make a schedule, we get a activity list at it, and after that we will this data progress, it will be represented by the Gantt chart as it show, and we could find a critical path from, and finally the total project duration is 34 weeks.
Hi, I'm Lu Haodong. My part is optimization. We can draw the AON diagram for this project based on the engineering schedule, identify the critical path, and marked it in yellow on the diagram. We want to complete the project within an ideal time, which requires crashing. The cost of crashing varies for different activities, and we need to find the optimal solution. We use Lingo software for linear programming. We must define the optimization objective, minimizing crashing cost, calculated as each activity's accelerated time multiplied by its crashing cost. Next, define the decision variables. By it means the time each activity can be crashed, and yi and xi. Then establish constraints for each variables. After the calculation, the results are shown in the diagram. Activity C, E, and G are crashed for 6 days, 4 days, and 3 days, respectively. Thank you.
This is my part, and my part is about our project cost estimations. And the estimation provide a comprehensive cost focus for the work of the public housings for the in the development areas. And all of our calculations is primarily based on the office schedules of the rate for turned contrast of buildings works, which is published by the Architectural Survey Department of the HKSAR government. All of this ensure that our estimation is fully compliant with the Hong Kong's public work standards and the market price, making it highly competitive and credible. And the purports show that this is our base information of our buildings. And this is the table that's our calculations about the cost estimations. And the tables covers all the works from the preliminary site setup and the foundations and the basement structures and also the superstructures. And through the details calculations, the total estimation cost for the base scheme is HKD 143.7 million. And finally, it is important to note that it is not a fixed figures because with the just during the project that we will be dynamically monitored and adjusted during the project. And our goal is to deliver the projects with high quantities within the baggage. And the next part will be my other teammates to show you.
Now, I will briefly present the project control analysis using earned value management by the 4 months of construction, representing 45% of our planned schedule. The project shows noticeable deviations. Our planned value is 58 million, while the earned value is only 52 million. The actual cost has reached 55 million from these figures. The cost performance index is 0.945, indicating a cost overrun. And meanwhile, the schedule performance index is 0.896, which means the project is behind schedule. Using CPI for cost forecasting, the estimate at completion becomes approximately 167.6 million, suggesting a potential cost overrun of around 7.6 million compared with the original budget of 160 million. This highlights the need for early intervention and tighter cost time control in the coming phases. And we have corrective measures. The first is increase the operation shifts of tower crowns. Second, adopt a large-scale formwork system to reduce formwork replacement time. And third, increase the proportion of fabricated components. And to conclude, this project demonstrates generally feasible construction plan supported by systematic WBS development, CPM scheduling, cost estimation, and EVM analysis. However, the early stage deviations reflected in CPI and SPI show that improvements are necessary. We recommend three key actions: strengthen progress monitoring by increasing reporting frequency and integrating real-time set data to prevent schedules slippage. Ultimate resource allocation, especially for foundation and basement works, to reduce inefficient spending. Implement cost control measures such as reassessing subcontractor productivity and revisiting inaccurate assumptions for high-cost items. By applying these strategies, the project team can bring the project back towards the planned budget and timeline, ensuring smoother execution in the remaining stages.